Dear students, today's session is going to be very interesting. In today's session, we are going to see what is meant by Cayley-Hamilton theorem and what is the uses of Cayley-Hamilton theorem. First of all, let us see the definition of Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. Uses. We can use Cayley-Hamilton theorem to find the positive integral powers of A. That means A square, A cube, A power 4, etc. The power should be a positive integer. And the second one is we can find the inverse of a matrix using Cayley-Hamilton theorem, provided the determinant of matrix should be not equal to 0. That is, it should be non-singular. If the matrix is singular, we cannot find the inverse. That is very basic to us. Let us go into the problem directly. Verify Cayley-Hamilton theorem and hence find A inverse A power 4. In your exams, either they will ask verify Cayley-Hamilton theorem with A inverse or verify Cayley-Hamilton theorem with A power 4, or they will ask this both. Now, it is very important. This Cayley-Hamilton theorem results will work for any square matrix. The matrix may be symmetric or it may not be symmetric. It doesn't matter. See this matrix. The row is 2 minus 1 2 and the column is 2 minus 1 1. So the matrix is non-symmetric matrix. So Cayley-Hamilton theorem will work for either symmetric matrix or a non-symmetric matrix. As usual, to use Cayley-Hamilton theorem, we need characteristic equation because every square matrix satisfies its own characteristic equation, and it is very important for Cayley-Hamilton theorem just found up to characteristic equation. Don't go for eigen values because we don't need eigenvalue. Why I'm saying this? Sometime in practice we start to find the eigenvalue, but the matrix which is given for the Cayley-Hamilton theorem verification or A inverse or higher powers, the eigenvalues may be in decimals. Then you may get confused and you may get misled. So whenever you see Cayley-Hamilton theorem, stop up to characteristic equation. So as usual, to find the characteristic equation, we have to find S1, S2, S3. We have practiced a lot about this finding S1, S2, S3 from the matrix. The S1 is going to be sum of leading diagonal elements. That is 6. Then S2, I have to find the minor of the leading diagonal elements. For the next one, we leave this row and column, and similarly for the third one we leave this row and column, and expanding this we will be getting S through equal to 8. Then similarly to find S3 we have to take the determinant, and I'm directly writing the answer because we have practiced a lot. So once you find S1, S2, S3, we have to go for the characteristic equation. Write the characteristic equation. Make sure the plus minus everything is correct. Next, according to our definition, every square matrix satisfies its own characteristic equation. That means in this characteristic equation, I am going to replace lambda by A. So it becomes A cube minus 6A square plus 8A minus 3. Here everything is a matrix. So the constant minus 3 will become I. It is very easy. I is the identity matrix. When the matrix is 3 cross 3, it is going to be 1 0 0 0 1 0 and 0 0 1. If it is 2 cross 2, it is going to be 1 0 0 1. So now consider this as equation 1. So this plays a major role to find A inverse A power 4 as well as verification of Cayley-Hamilton theorem. Now we have to think little. Doing matrix multiplication is not an easy job. When we go for a 3 cross 3 matrix, it is going to be little tough. So that's why I said we can go for the calculated tricks. Calculator is there. I am just using Casio 991 MS. You can use any equivalent which the provisions are there to do matrix multiplications. So as usual, clear your memory, do all these things by pressing shift mode and then choose 3 and then press equal to equal to. It will clear your all memory. Now let us go and press mode 3 times. We'll be getting this. This time I'm going to do matrix operation. So I'm going to choose mat. When you press 2, you can see the screen like this. You can just zoom it. You can see the matrix mode is enabled. That means your calculator is ready for the matrix mode. Next, press shift plus 4 to do all matrix operation. Remember, throughout this video, shift plus 4 will give all the matrix data. When you press shift plus 4, if it is showing like mu, that means your calculator is not in matrix mode. Sometimes what we do, students will not enable the matrix mode. You see there is no mat here. If they don't enable the matrix mode and they will come for directly shift plus 4, it will not work, it will show mu. So now clear your memory and go back to the steps, press mode 3 times again, press 2 to get matrix mode. So once it was in the matrix mode, once you press shift plus 4, immediately it will show the display like this. First, for a matrix, dimension is very important. Dim means dimension. We have to enter. Here we are dealing 3 cross 3 matrix. So we are going to enter my rows. Rows are here M and columns are here N. I have 3 rows and 3 columns. First press 1. Once you press 1, it will ask the matrix. I am going to choose the matrix A. So press 1 to choose matrix A. Now it will show the display like this and we have to enter the value. For our dimension, the rows is 3. So press 3. Once you press 3, press equal to button. Then the calculator will ask like this. N1. 1 is some default value. Don't want to worry about it. I want to press 3. Once you press 3, press equal to, then it will start asking the matrix value. So we know the position 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. So these are all the position for the given matrix which is displayed here. We have to enter the value one by one. So for mat 1 1, I am going to enter the value 2. Enter the value 2 and press equal to. It will ask 1 2. 1 2 value is minus 1. Then enter minus 1, press equal to. 1 3 value is 2, enter 2 and press equal to. 2 1 value is minus 1, press minus 1 and press equal to. Similarly, 2 2 value is 2 and 2 3 value is minus 1, 3 1 value is 1 and 3 2 is minus 1. Finally, 3 3 is 2. When you press everything with equal to, now press AC button because the calculator again will come and stop in the position mat A11. When you press this AC button, your calculator stores your matrix A. So now matrix A is ready to do the operation. Very simple. So slowly watch the video either once or twice to get all the points. Next, first we have to verify Cayley-Hamilton theorem. For the verification, I need to find A square and A cube to verify the Cayley-Hamilton theorem. First I have to find A square. So A square is nothing but A into A. It is very important. Write the matrix twice. Now my job is to find this A square not by doing matrix multiplication using my calculator trick. Now take your calculator. As I said, to do matrix operation we always need shift plus 4. Press shift plus 4. It is asking dimension edit mat. Now I don't need dimension. Dimension is already entered. So I am going to choose the matrices. If when you press 3, you will be getting this display. Now our data is entered into matrix A. So choose 1. Once you choose 1, it will show the display like this, mat A. I want to find A square. So you can see the button x square in your calculator. Press the x square button to find the matrix A square. So the display will be like this. Once you press this, press equal to button, start seeing the display. For 1 1 it is 7. Now it is very important you have to press the right button in the calculator, because if you press the down button it will go for the next column. We need to fill this A square like this. The positions are 1 1 1 2 1 3 etc 3 3. Hope you understand. So when you press right button, it will show 1 2 value, then 1 3 value, 2 1 value. Then when you press right button, 2 2 value, then 2 3. Similarly 3 1 3 2 and 3 3 value. So now your matrix A square is ready. So side by side you have to copy the value in your note. Okay, now the A square matrix is ready. Now press AC button because to do the next operations. You see the A square matrix I get from the calculator in a very easy way without doing matrix multiplication. Similarly, next we have to find A cube. To find A cube, just write A square into A square is there and A is there. Write the matrices. Now again take your calculator, but it is very important, never press on button. If you press this on button, all your memory get erased. You have to enter the matrix value again. Now press shift plus 4. It will show dimension edit mat. Now I have to choose mat. So choose 3. Then you'll be getting the same thing. I have to choose the matrix A. Now your calculator will show you the display mat A. Press shift plus x square because I want to find A cube. Press shift plus x square button, then we can see the display A cube. That means we are going to find the A cube matrix. So once you press this, press equal to button, then we can see the following display. As usual, I am going to write the A cube matrix directly, like this is the value 29, then 2 1 2 position, 1 3 position, 2 1 2 2 3 1 3 2 3 3. So we can see the display 1 2 position, 1 3, 2 1 position, 2 2, then 2 3 position, 3 1, 3 2, and finally 3 3 position. Just copy down the values from the calculator. It is very useful. You don't want to find A cube also. Now we get all the entries in the matrix A cube. Press AC button again and then write the A cube value. So we know A square value, we know A cube value. First step, I am going to do the verification. So LHS is going to be A cube minus 6A square plus 8A minus 3I. That is we get from the Cayley-Hamilton theorem. Write A cube value, then minus 6 into A square. Just write the A square matrix plus 8 into A matrix minus 3 into the identity matrix. Write one by one. Now 100% if your calculator values are correct, then there is no error. I can directly write my RHS. When you simplify it, I am going to always get the null matrix. So you don't want to do any simplification, directly you write. So verification gets over because if your A cube A square matrix is correct, then this will be exactly the null matrix 3 cross 3. Cayley-Hamilton theorem is verified. Next we go for A inverse. To find A inverse, take the original equation, that is 1. Now pre-multiply by A inverse in 1 on both sides. It will become A square. This will become minus 6A plus 8I, and you will be getting minus 3 A inverse. Right hand side is going to be 0. Now I want this A inverse. So I am writing 3A inverse is equal to A square minus 6A plus 8I. And you should be very careful. Calculator can easily find A inverse. But if you bring the 3 to the other side, it will give decimal values. So never bring any values which is multiplied with A inverse. Keep as it is. Find that value using your calculator. Finally write the value to the other side as the denominator 1 by 3. Now I am going to find 3 into A inverse, not simply A inverse. This is very important, student. I don't need this. I want to find this. And finally I'll write A inverse is equal to 1 by 3 and the matrix which I found from the calculator. So we are going to use the calculator, but according to Cayley-Hamilton theorem, we have to enter A square value minus 6A, 8I, everything like this. Just for exam point of view, you write everything. If you simplify, you may get the answer. I never say it is incorrect, but you may do some minus plus error. So better go to the calculator, get the answer, write the answer immediately. Now to find 3A inverse, first we have to enter 3. So press 3 in your calculator and then press shift plus 4 to enter mat. So dimension will come. Now choose mat and then press 3. I have to choose matrix A always because I'm enter all the values in A. Then the calculator will show you 3 mat A. Now you can see x power minus 1 or x inverse button in your calculator. Press that button to find the matrix A inverse. So now the display will show 3 mat A inverse. Once you press equal to button, it will start showing the corresponding A inverse value. So 1 1 position is 3, 1 2 is 0, 1 3 is minus 3, 2 1 is 1, 2 2 is 2, 2 3 is 0, 3 1 is minus 1, 3 2 is 1, and 3 3 is 3. Now side by side write the values of 3A inverse. You write the matrix in your note or in the paper. Once it is done, then press AC button. Now you can see the values. I don't need this value because this is 3A inverse. I want A inverse. So simply write 1 by 3 and then write this matrix here. So this is going to be your A inverse, students. It is going to be very, very easy. Just write A inverse 1 by 3 and what we found from calculator. So now the second part of the problem is also done. Next we are going to find the higher integral powers, that is A power 4. To find A power 4, we take the equation 1 and then rewrite it as A cube in terms of other values, 6A square minus 8A plus 3I. Now if I pre-multiply by A on both sides, I'll be getting A power 4. So we know the value of A cube, A square, A. Just substitute 6 into A cube minus 8 into A square plus 3 into A. Now either you can simplify this, but still it is very tough because you may do some error. We can go for calculator. As usual, press shift plus 4. It will show you choose the mat A because the mat A is stored in your calculator. So it will give the display A, B, C, D. Then choose A1. It will show mat A. Now I want to find A power 4. There is two options you do. Mat A square into mat A square. That you can do. Or the simplest way is first press X square button. You will be getting mat A square. Then again press X square button. You will be getting mat A power 4. The concept is very simple. Mat A square, if you press square, that means the calculator knows that mat A square and I have to do square. So mat A square into mat A square will give you mat A power 4. You can see the display like this when you press X square twice. So now press equal to button to get the A power 4 value with the positions 11, 12, 13, 21, 22, 23, 31, 32, 33. It's simply 1, 1. I'm saying like that. So you can see the 1, 1 position value. Press right button 1, 2, press right button 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. So write the value in your note or material or the paper for A power 4. So now we get all the entries of A power 4. Problem gets over. Now press AC button and write the A power 4 value. And many students are asking doubt if your calculator is stuck into matrix mode or equation mode. End up the problem. Again press shift plus mode and then choose 3 and press reset all equal to. Now your calculator was cleared from all the memories, whether it is matrix or it is equation mode. All the modes will be clear and it will come into a normal mode. So now we found A inverse. We verified Cayley-Hamilton theorem. Then we found A power 4. So we can do this for any 3x3 matrix, whether it is symmetric or non-symmetric, doesn't matter. Use the calculator, enjoy your problem, get the full score, subscribe our channel, share to your friends, let everyone get benefited. See you in the next video. Bye bye.